The best way to work this problem is to build yourself the table that relates all of the quantum numbers. So we know that the value of n starts with 1 and gets bigger. So 1, 2, 3, 4. This tells you the shell the electron is in. And we're going to focus on the, oops, not that one, the n equals 3 shell. Then you would do your L, and you know that your L goes from 0 up to 1 less than n. Now I'm not going to worry about all the others, but I'm going to look at this 3 and I'm going to build out all the possible values of L. It can be 0, it can be 1, and it can be 2. Okay, so these are the possibilities of L for an n of 3. This is your D, your S, your P, and your D subshells. Then let's build out all the m sub L values. They go from a negative L to a positive L. So for an L of 0, m sub L is 0. Writing one number here tells me that there's one orbital, because this last number tells you the different orientations of the orbital, and there's only one s orbital. P goes from a negative 1 to a positive 1. That tells you there are 3 orbitals. D goes from a negative 2 up to a positive 2. This tells you that there are 5 d orbitals. And so these are all the possible quantum numbers for n equals 3. So let's look at this. If n equals 3 and that's all we're doing and all we're giving you, that it means all of these orbitals that you see right here, every one of these orbitals have an n equal 3. Well, how many orbitals are there? There's 5 plus 3 plus 1. That's 9 total orbitals. And each orbital will hold 2 electrons. So that would be 18 electrons. All right, the next one defines it a little bit more thoroughly. It doesn't just tell you how many, what subshell it's in. It is going to give you an n of 3 and, what happened to my pen? It's not writing anymore. Oh, there it is. An n of 3 and an L of 2. Okay, if you define those two, you've said I'm in the third shell, I'm in the D subshell, and we're going to be talking about all of these orbitals. And there are 5 orbitals, and each orbital holds 2 electrons, so that would be 10. The next value that we're going to look at is giving you a little bit more information. We have an n of 3, an L of 2, and an m sub L of 2. So we're getting down to this m sub L right here. So when you've defined all 3 of those numbers, you've defined a specific orbital. That's only one orbital right there. That one orbital will hold 2 electrons. So that would be a value of 2. It takes 3 numbers. It takes the n, it takes the L, and it takes an m sub L to define a specific orbital. But the next one gives us just a little bit more information. The next one also gives me a m sub s of a plus 1/2. So I'm in the same orbital, but I'm defining a very specific electron, an electron that is spinning in the negative 1/2 way. So this has to be a single electron. When you have defined all 4 quantum numbers, you have defined right down to a very specific electron. It's where it lives, it's in the 3D subshell in a specific orbital of that subshell, and it is spinning in a specific direction.